morning, everyone in Pacific time zone, and greetings to everyone in whatever time zone you're in. Welcome to today's webinar. My name is Harsh Nayak, and I am a senior solution engineer for MySQL working for Oracle. And we will begin this webinar now. So here is our safe harbor statement. It just basically indicates that whatever is presented today is meant for information purposes only and shouldn't be incorporated into any contract. So with that, let's focus on today's program agenda. So we will start with some of the highlights of major features until the release of version 8.023, and then talk about the new and exciting features that we have built in version 8.023. Now, I have also reserved some time to talk about our new cloud offering, which is MySQL database service in Oracle Cloud, and its super fast accelerator, which is called HeatWave. And we will then provide some references of our customers. And finally, we will conclude this session with a Q&A session. So let's kick it off with the first topic, which is what we have done so far. So why there is a need to upgrade it to MySQL 8? First of all, MySQL 8 was a biggest advancement over its previous version, which was MySQL 5.7. It's twice as fast and it has got improved reliability and improved security. What we highly recommend to our customers is if you're using any MySQL version 5.7 or lower, then it is highly recommended that you upgrade it to MySQL 8 to get the full benefits of its latest and greatest features. And of course, please make a note that if you are trying to upgrade, first make sure that the upgraded version is compatible with your existing workload. And just a note for users who are still on MySQL 5.6, please note that it has reached the end of life cycle for the support just over a week ago. So why MySQL 8? Here's all the reasons. Because it has got all the right features. So if you look at some of the most important features of MySQL 8 over its predecessor, it has got many features ranging from performance, reliability, ease of use. So for performance, they have got all sorts of optimizations, table and index partitioning, faster DDLs, online DDLs, the parallel data imports, scaling up and down. In terms of reliability, they got stored procedures, triggers, views, transactions, ACID compliance, basically. And for ease of use, you got the MySQL Workbench, the JSON support, the MySQL Shell, which is very popular and very easy to use tool. In terms of security, you got stored procedures, advanced password management, the TLS 1.3 support, and the SHA 256 for passwords. It's very developer friendly. It has got the document store for with the CRUD operations. MySQL Shell is very easy to work with for developers, and the common table expressions, window functions that we have introduced with version 8, some GIS functions as well. And the most important thing is enterprise ready. So you can monitor with MySQL Enterprise Monitor. You can also do advanced backup. You can do thread pull plugin, and you got external authentication. So there are many other features which are not listed here, which make it very important for users to upgrade it to MySQL 8. So at MySQL, we have the continuous delivery model. So whatever new features that we develop or the bugs which are fixed, they're all part of the quarterly release. The latest quarterly release, which is 8.023, was released just little less than a month ago on January 18th. And you can go to the URL which is displayed on the slide here and check out our current and previous releases for specific information on each release. This slide presents some of the important features that we have released in the last 5 releases. So as I mentioned, we do the quarterly releases. So for year 2020, we had 4 releases. So all the versions from 8.019, 20, 21, 22 were released last year. And we just released 8.023 last month, which is today's webinar's topic. And I'm not going to go in the details of every single topic here because in the interest of time, it will not be comprehensive to cover all those topics here. But you can go and check the website and find out all those details in that documentation. So let me give you some highlights of what are the most important features of 8.0. And they are this transactional data dictionary, roles, window functions, common table expressions, InnoDB replica set, and the document store. And we're going to take a look at each of them in slide details in the next few slides. So the first is transactional data dictionary. So with MySQL 8, all the metadata are stored in InnoDB tables. So if you're familiar with the older versions of MySQL, which is 5.7 or lesser, the default engine, the storage engine, which is MyISM, it's a non-transactional storage engine. So your data dictionary, it is stored in those .frm or .opt or .par files. But with MySQL 8, we have changed this, and all your data dictionary, all your metadata, they are stored in InnoDB tables now. The next is roles. Roles are nothing but collection of privileges. They can be granted just like individual privileges, and they can also contain other roles. You can imagine roles as a convenient way of adding or removing and managing grants in your database. Now, I have a background in Oracle database development and administration for myself, where I have used role as a very powerful feature, uh, basically a security feature that could help in keeping the entire database safe. With MySQL 8, we have introduced roles in the very similar manner that they are in Oracle. And roles are basically implemented in a very similar way to users. Basically, they're stored in the user table. The names consist of the user and host. The important distinction between the users and the roles is you cannot log in as a role. You can provide the name of the role and the host when creating a role in the same way as you would when you're creating the user. So here is how you can do that. You can just write this command, create role, followed by the name of the role and maybe the name of the role and the host name, just like you would do with the users. The next is window functions. Window functions are available beginning MySQL 8.0, which allow you to solve your query problems in new and easier ways and with better performance. And they gather the results into a set of rows and return a single aggregated value for each of the rows in the result set, as opposed to when you're using aggregate functions, they tend to reduce the row sets and they just reduce it to that individual group. So in a nutshell, they provide a very practical tool for estimations and rankings, and we all know the power of window functions that can help us in analytics. The next is common table expressions, which is also known as with queries, is a named temporary result set that exists within the scope of a single statement, and that can be referred to the later within that statement. So here is how let me just grab the pen here. So as common table expression, they begin with clause, and then you can define CTE1 or CTE2, and then those CTEs, they can be later used as part of the select statement that you're trying to use. So CTEs in that way provide better readability and the performance in comparison with a derived table. The next one is InnoDB replica set. This one is one of my favorites. The replica set is a quick and easy way to get your MySQL replication and router up and running. So if you are familiar with the traditional MySQL replication, you know that you have to do lots of manual tasks of setting up the channel, setting up the replication users, copying the data to the replica, and many other manual things. But with InnoDB replica set, it automates all those tasks found in that traditional process, like configuring, adding, and removing members, and automatic member provisioning using the cloning method. It provides the manual failover capabilities in use cases that do not require the high availability offered by InnoDB cluster. And actually, with version 8.023, we are also offering some automatic failover capabilities as well, which we will take a look at later in this webinar. So the main use case for replica set is if you want to scale out your read operations, that's the perfect use case. And the last is the document store, which allows developers to work with SQL relational tables and the schema list JSON collections. It also utilizes all the advantages of MySQL group replication and InnoDB cluster to scale out applications and achieve high availability. The document store provides multi-document transaction support and full asset compliance for schema-less JSON documents. With InnoDB as the storage engine behind the document store, you get the same data guarantees and performance and advantages as you do for the relational data. Basically, this guarantees that users get the data reliability with complete data consistency. And the most important thing with the document store is because you get both your relational and non-relational aspect into a single database, thereby it reduces the effort that to maintain two databases and thus by reducing the costs. Now, after all the important features, highlights of what was in MySQL 8, it's time to dig into what is new in 8.023, which is precisely today's topic. So there are many features that we have developed or released in MySQL 8.023, but in the interest of time, I'm just going to focus on some of the important features for this webinar. So they include this invisible columns, the query attributes, some security features, some enhancements that we have done in InnoDB and GIS, the Geographical Information System. The replication has also some enhancements, and so this X protocol and some of the variables and commands have been deprecated. And we're going to discuss all these good things in the next upcoming slides. Starting with invisible columns. So the invisible columns, as the name suggests, they are invisible or hidden to the queries. So how can you access them? Well, they can be accessed by naming them explicitly in the query. So for example, here, this is the table that you're trying to create, and this column one is the regular visible column, but you're trying to create this column two as an invisible column. So that is how you define invisible columns. And when you're trying to insert the data, you have to explicitly name it. And so when, let's say you're trying to access the table, all the columns using select star, since this column is invisible, you will only receive column one over here because that's the only visible column for the table. So if you want to access column two, then you have to explicitly put the name over here because it is invisible column, and then you can get the data over here. Now, you must be wondering, what is the use case here? Why do you need it? So basically, let's say for application migrations, this is very important because just I gave you this example in this. Let's say if you have your new application, which has a table with two columns. And for the older version, it is basically written this way, select star, so that if you add the new column, then basically you just want to see how it will look like with the newer version. You can write this select column one, column two in the newer version, and the older version still works well with the invisible column. So that's the use case. The next is query attributes. This feature is based on the contributions from Facebook, which is a very heavy MySQL user. With this feature, clients can now define query attributes that apply to the next statement sent to the server for execution. The attributes are defined prior to sending the statement to the server, which can exist until the statement execution ends, and at which point they automatically vanish. And while the attributes exist on the server, they can be accessed, the server can basically access their values. So what is the need for query attributes? What is the use case here? So let's say if you have a web application that produces pages that can generate database queries, and for each query, you must track the URL of the page that generated it. So that's one use case where query attributes can be used with those database queries. And the second would be, let's say you have an application that passes extra information with each query for, so that particular information can be used by plugins such as audit or query rewrite plugin. So these are two of the use cases in which you can make use of query attributes. Let's take a look at an example. So in order to use the query attributes, you have to first install the components. The component is very simple. You just issue this command install component and then file // component query attributes. And once the component is installed, basically you can make use of the query attributes. So in this case, you define the query attributes n1 and n2 with the values v1 and v2. So both the variables are defined over here with the query attributes. And now if you want to access them, the way you can do it by putting it into the select statement, and you use this MySQL query attribute string function to access their values. And this function is available after you install this component. So here I'm trying to access the values of n1 and n2 as attribute 1 and as attribute 2. And notice that I'm also trying to access n3, which I haven't defined over here. So if I execute this statement, what result am I going to get? So I'm going to get the value of v1, which is for n1, value of v2, which is for n2. And since n3 is not defined, it is going to be returned as null. So if the query attribute has a variable which is not defined, then basically it's simply returned as null. And as I discussed before, once the values are accessed on the server side after the execution of this statement, if I try to execute the same value again, if you remember, I said it vanishes. So both attribute 1 and attribute 2, n1 and n2, they will be presented with null now. The next is GIS, in which we have added two new functions, fresh aid distance and the Hausdorff distance. Basically, both of them, they return the discrete distance between two geometric entities, reflecting how similar the geometries are. And here is the number that basically comes up as the result of executing both the fresh aid distance function and Hausdorff distance function. Next is security features. Let's begin with the encryption of the double write buffer. So before we go into this feature, let me give you a little introduction of what double write buffer is. Basically, it's a storage area where InnoDB writes pages flushed from the buffer pool before writing the pages to their proper positions in the InnoDB data files. Now, currently, all the pages in double write buffer are unencrypted. So, which means that even though pages that are belonging to encrypted table spaces, they also go unencrypted before being flushed to the data files. So with this new feature, what we are trying to do is we are trying to enhance the security of the double write buffer and ensure that the pages in double write files belonging to encrypted table spaces are also encrypted. So you want to make sure that these encrypted pages they they have been belonging to this encrypted table spaces, and we have to encrypt it in the double write buffer. But at the same time, if the pages that belong to unencrypted table space, then they must remain unencrypted as well. So we only want to encrypt the ones which are supposed to be encrypted. And the encryption key is the same encryption key that you are going to be using for the respective table space. How can you do this? How is it achieved? Basically, if the transparent compression is enabled for the table space, then do the compression. And then if encryption is enabled, then encrypt the tables, encrypt this using the same table space key. Then flush the compressed and encrypted page to the double write file. And then finally do the flush the compressed and encrypted page to the data file of the table space. The next security feature is more granular privilege control of the flush operations. Now, if you're familiar with the MySQL reload privilege, then granting the reload privilege enables the user to perform a wide variety of operations like flush host, flush logs, flush privileges, flush status, and many more. But in some cases, it may be desirable for a user to be able to perform only some of these operations and not all of them. And you, as a DBA, you do not want to grant all those expensive or reload privileges to every user out there. So in order to avoid granting this reload privilege and tailor user privileges more closely to the operations permitted, these new privileges are more limited in scope and they are available with version 8.23. So for example, if you have optimizer cost or status or user resources or tables, you can just use them without the need of the reload command. The next feature is faster truncate or drop table space. Now this feature has been requested from many of our users because it's a cause for server stall for many of them. So let's understand the process behind what goes on when you issue the drop table or table space process. So the first thing is the InnoDB buffer pool adjustment. So any dirty pages that are relating to this drop table space, they have to be cleaned up. Then the next step is to clean up the AHI indexes, which is adaptive hash indexes. And the last is the deletion of the file on the file system. Now that's a very simple process. But where is the problem? The first two, basically, they cause the server to stall. And why? Because whenever you drop the table or table space, then what happens is the InnoDB buffer pool has to traverse the whole buffer pool for the dirty pages, and that takes a long time. And until then, you cannot process any DML statements or any other operations concurrently. The cleanup of AHI indexes also takes some time, but it's not actually used in a lot of other places. So the main cause is the InnoDB buffer pool adjustment. The last operation is not that big. It's very easy. But the problem is the bigger the buffer pool, the worse it gets. And I'll explain you how it works. So let's say here you have your buffer pool, and so this is your buffer pool. And when you issue your drop table or table space, then what happens in the first step? Let's say you have this dirty page over here, maybe you have one over here, and maybe you have one over here. So you're traversing, first you come here, you get rid of this page from the buffer pool, and then you come here, and then you get rid of this, and then you go all the way, and then finally you get rid of this page. So until this process is finished, you cannot continue with the DML operations. And the big problem when I say it gets worse with bigger buffer pool sizes. So let's say you have this bigger buffer pool, and let's say it is more than 500 gigabytes. Okay, so in this case, what happens is, even let's say if your table is empty or your table space is empty, basically it has no dirty pages, but it still has to go through the traversal process. And until it reaches here, when it finishes, the DML operations cannot continue, which essentially causes the server to stall. So what are we doing to make this better? Well, the solution is we are trying to make it almost instantaneous. And how are we doing it? Basically, we are trying to free the pages in the buffer pool lazily instead of immediately. So we're getting rid of this first part over here. So this whole process where you're trying to uh, clean up the dirty pages from the buffer pool no longer exist. So these buffer pool, they can be evicted later on when InnoDB buffer pool is trying to evict the pages from the buffer pool using the least recently used algorithm, we can handle the cleanup of the buffer pool at that time. And then as long as you're not using the AHI indexes, you can just go ahead. I mean, the MySQL can just go ahead and delete the file from the file system, and the operation is almost instantaneous. So the operations which are affected when you issue the command drop table space, or if you issue the drop table or truncate table in a file per table table space, or when it is an implicit temporary table space truncation. We have seen the performance up to 251 times faster here. And we have an example over here. We have carried some test cases in which this x-axis represents the buffer pool. So the tests have been carried with different buffer pool sizes ranging from 32 gigabytes, 64, 128, all the way up to 450 gigabytes. And the y-axis represents the time in seconds, basically. So here, basically what we have done is we have created a big table and fill it up with the data about the size of the buffer pool. So in this case, the table is filled up with 32 bytes of data, and in this case 450 gigabytes. And then we try to create and delete 100 empty tables concurrently. Now, as you can see with version 8.021, which is represented using the blue bar over here, as the size of the buffer pool increases, you see the performance gets worse. So the cause of the server stall gets worse. But with the improvement in 8.023, which is presented by this orange bar over here, as you can see, it's almost instantaneous. So the performance is very fast. The next is table space auto extend size. So whenever the table space runs out of space, it is extended per this auto extend size variable, which is default 0. Now, the current growth size is hard coded to 1 MB, and that 1 MB is calculated using the page size times the number of pages in the extent. With the default page size of 16 kilobytes and 64 pages per extent, it comes to 1 megabyte. So why do we actually need this? The reason why we need this is because the 1 megabyte space was actually sufficient on hardware from 20 years ago. But with today's loads, this becomes the bottleneck. So then you need to let the table spaces, all the tables in file per table table spaces, use this auto extend size feature so that when you're trying to ingest high amount of data, it doesn't end up getting fragmented over this 1 megabyte segments. So with that, we have used this auto extend size, made it available, and it has to be the multiple of 4 megabytes. And that's basically calculated by keeping in mind the size of the page and the extents. So the minimum size you can define for the auto extend is 4 megabytes, and the maximum you can define is 64 megabytes. Now with the replication, there has been a few enhancements in the replication features. So as you can see, the traditional replication uses the terms like master and slave. And we mentioned in 8.021 that we will stop using these offensive terms. So with this version, we have made some progress towards this goal. And so we no longer want to call this the master and slave. They are going to be replaced using the source and replica. So the commands that come with it, which are change master and start slave. So if you're familiar with those replication commands, then the change master and start slave commands, they are replaced with change replication source and start replica. So this master is going to be replaced with the source, and the slave is going to be replaced with replica and all its parameters. And does it mean that the old commands will not work anymore? No, it does not. You will still be able to make use of those commands, and when you use them, a deprecation warning will be emitted. But we encourage our users to make use of the new commands because those old commands are going to be removed in future releases. The next replication feature is how to replicate from a non-GTID source to GTID replica. Now, for those of who do not know GTID, GTID stands for Global Transaction Identifier, and which is as useful in assigning the transactions happening in the servers, the transaction identifiers, which is at the global level, and that can be used, that is unique to each server and can be used for replication purposes. Now with this feature, what it does, it enables the replication from a source server that does not have GTIDs enabled, or it does not support the GTID based replication, to a replica that has GTIDs enabled. And you might be wondering, why do we need to do this? And there are several use cases, some of them being, let's say you want to replicate from Cloud X, which does not have the GTID support, to the MySQL database service on Oracle Cloud, then that is the first use case. If you want to migrate your on-prem deployment with GTID mode equal to off to MySQL database service again on Oracle Cloud, you can do that. And let's say if you have your existing workload, which doesn't have the GTID turned on, then you first might want to pre-check how it would look like if the GTIDs were to enable. So these are some of the use cases which are applicable to this particular feature. How you can do this, if you're familiar with the replication commands, then this change replication source to statement, you just use this assign GTIDs to anonymous transactions. The by default, it's off, but you can use the values local, which will use the UUID of the server of the replica, or you can just simply define some other UUID. Now, why do you want to define a UUID? Is because if you're trying to distinguish the transactions that happened on the local server versus the one that came from the source, you want to use the other UUID to distinguish between those two transactions. The next is automatic connection failover for asynchronous replication. This new feature implements a mechanism in asynchronous replication that makes the receiver automatically try to reestablish the asynchronous connection to the sender, which is not, so in this case, let's say if you have failed sender, it will try to connect it to the other sender if that sender, which was originally connected, goes down. So this is, if you are familiar with the MySQL replication, traditionally it's an asynchronous replication and the failover capabilities are all manual. So you have to set up the replication user, set replication channel, and if in some case the source goes down, the replica has to connect to an alternative source manually. So with this, we are trying to mitigate that feature by allowing the automatic connection failover when you're using the asynchronous replication. Now, before we get into the details, let's first try to understand the terminologies which we'll be using in the next few slides. So the first is sender. It's self-explanatory. The endpoint that sends data, receiver, which is something that receives data. The sender list is a list of multiple senders with weights assigned to each sender, basically. So you can have multiple senders and they all have different kinds of weights assigned, and the weight could be a number between 1 and 100. And just to make sense out of all these things, let's try to look them in the practical examples. So here is a standalone example in which you have, let's say, three senders. So in this case, for this particular receiver, the sender list consists of sender 1, 2, and 3 with different weights, 90, 80, and 70. And the asynchronous replication is set up between sender 1 and the receiver. And the receiver has its sender list listed as sender 1, 2, and 3. So in this case, if for whatever reason sender 1 goes down, then this replication link is broken. So what happens next is, because of the automatic connection failover feature, the old link is disconnected, and the receiver will be able to connect to the new sender based on the weight of in the priority list. So in this case, the sender 1 is no longer from part of the sender list, and sender 2 becomes the source for this receiver. Now we have made this feature available to group replication also starting from 8.023. So with this, let's say if you have the group replication consisting of two members, so in this case, both sender 1 and sender 2, and a new member wants to join or leave the group, how it will behave. So let's say we have this new member and all of them, just for the sake of simplicity, we have used the weight 50, so equal weight. So if it wants to join the group replication in here, then as soon as the member joins the group replication and is available, the sender list on the receiver side is updated with the sender 3. So all the senders are part of the sender list on the receiver side. Now, for whatever reason, one of the member decides to leave the group. So let's say in this case, again, sender 3 goes down. Let's say there's a crash happen, is no longer part of the group replication, and it has to go out. So in this case, what happens is sender 3 leaves the group, and the sender list over here is updated as well on the receiver side, and it just contains now sender 1 and sender 2. Next use case for group replication is what if the member loses the quorum? So you have the group consisting of 5 members over here, and all of them, they carry the equal weight, and the sender list over here consists of all the 5 members. Now, what happens if the quorum is broken? So S1 and S2, basically, they can no longer be reached from S3, S4, or S5. So in this case, the S1, sender 1 and sender 2, they lose the majority. So what happens next is basically S3, S4, and S5, since they are the majority, it can basically connect to the receiver, basically can connect to any of this sender because they all carry equal weights. Now, for the sake of simplicity, I have just chosen S3 for this example, but it can also connect to S3 or it can also connect to S4. The next is the new member with the high weight when it joins. So let's say in this case, you have a new member which is with the weight 70. So in this case, both of them, they have weight 50 and 60, but the new member has 70. So when it joins, the old link, which was from sender 1, which was carrying the weight of 60, is no longer valid because the new member with the high weight joins. So the sender list has to be updated over here, and the replication link has to be set up from the new sender as soon as it is available. And what happens if the primary membership changes? So for example, in this case, you have the group replication consisting of 3 members, and your primary is sender 1 with the weight priority of 60. Now, what happens if this primary changes to sender 2? So in this case, the sender 2 becomes primary with the weight of 60, then this link is no longer valid. So what happens is that link is broken, and it's adjusted with the new primary, which is carrying the high weight. And the sender list is also updated, and the receiver is going to continue receiving the updates from the new primary. So these were all the replication related features. Now let's talk some X protocol related changes. The first is the connection alive in the service command. So the SQL that use metadata lock and the sleep function periodically test a connection to see if it's alive or not. And this functionality helps in case of long-lasting queries where it's essential to stop them and free their sources. Because if you don't release them, you might get the denial of service. And this is already implemented for the classic protocol, and now it's implemented in X protocol as well. And the next for X protocol is notice on shutdown. So the notice on shutdown basically just tells the clients that, hey, if something happened, you just close the connection, the server shut it down by itself or whatever. Why this is important is because the clients can actually use this information to decide if it makes sense to reconnect or to try again. Because if the server is dead, you might want to go somewhere else and not connect to the dead server, right? And the last one that I want to talk about with 8023 are some deprecation and removal commands and variables. So the first is we have deprecated the relay log info repository and the master info repository variables. So if you still try to set these variables or read these variables, basically they will just emit the deprecation warning. But we encourage our users to use the table repository instead of these variables anymore, because they can be set in the table repository. And the deprecated command, which is flush host, with this version will be deprecated, and we encourage our users to use the truncate table performance schema dot host cache table instead. So with this, I know this is a lot of information, but I hope all these good features, they can be very useful to you guys. And they're all very good and exciting features. And before we move on, I'll try to now spend some time giving some highlights about the new MySQL offering in Oracle Cloud, which we call the MySQL database service, and its add-on engine, which is the Heatwave, which is sort of query accelerator, which accelerates your queries at a crazy percentage. So let's try to understand what this MySQL database service and Heatwave actually does. So the MySQL database service is easy, secure, and enterprise-ready service available in Oracle Cloud. It's easy because it's fully managed database service, which can automate all your time-consuming tasks, such as patching, upgrades, and backup. It comes with instant provisioning to get applications into production faster. And it comes with latest features that can deliver modern cloud native database applications. So all the features that we discussed here and all the ones that we're going to be releasing in future releases, they'll all be part of this service right when we release it. It is secure because it comes with data protection features like encryption, masking, auditing, and many more. It has some advanced security features to help you meet your regulatory compliance requirements. And it comes with the latest security features to limit your exposure to security vulnerabilities. The most important part of this service is it is enterprise ready and it is built on the MySQL Enterprise Edition. So the difference between the service in Oracle Cloud and in other cloud providers is that in other cloud providers, you get the community version of MySQL or some forked version of MySQL, but only in Oracle Cloud, you get the enterprise version of MySQL. So basically all those premium features that come with the enterprise edition, they're all part of the MySQL database service in Oracle Cloud. And it's 100% compatible with your on-premise MySQL deployments, and it's built on the Gen 2 cloud infrastructure, which offers core-to-edge security for enterprise workloads. Now, as with most other cloud services, as you can see, the various tasks are automated for the MySQL database service across the entire stack. everything you typically need to manually take care of in an on-prem environment in terms of hardware, storage, the OS, MySQL, everything is automated. And the pricing, as you can see, we have made some price comparisons if you are using the similar kind of configuration. So with in Oracle Cloud with the standard E3 shapes and with the 100 OCPUs, which roughly translates to 200 core CPUs and 1 TB storage, and these are the similar configurations in the competitors' clouds. As you can see, the price is like way down here over here. So if you're trying to use the same configurations in other competitor clouds, the cost of saving is enormous. And the next, I would like you guys to introduce to the Heatwave, which is an add-on to the MySQL database service, which is the crazy accelerator that comes with the MySQL database service, which is massively scalable analytics engine, which can process your analytics queries very fast. So here are some of the comments from Larry Ellison from our earnings call on 10th December last year. And he mentioned that MySQL plus Heatwave processes queries hundreds of times faster. And the amazing thing about Heatwave is that you don't have to move your data out of MySQL, and because that's the same database that you'll be using for both your online transaction processing and the analytics data processing. So let's try to understand what it does actually. So the analytics on MySQL has always been challenging because MySQL is traditionally optimized for transaction processing. So if you want to process analytics traditionally, what you do is basically you have to migrate the analytics to some different place, and you need to, in order to do that, you need the data migration, the ETL process, and you end up with two databases. And basically you can't support real-time analytics because your transaction database is here and your analytics database is somewhere else, so they cannot be real-time analytics. So with this Heatwave, what we have done is we have introduced the in-memory analytics and nodes with which are tightly integrated with the MySQL database service node. So anytime the transactional database is updated, it automatically pushes all those changes to the in-memory analytics nodes. So with that, all your online transaction processing applications, they can continue connecting to the MySQL database node. But the best part is if you're trying to run the analytics, now you don't have to go anywhere else. You can just connect to this Heatwave node, and all your analytics, they're processed using the same database service, same platform in the MySQL platform. So basically, it eliminates need for two databases, and the same MySQL syntaxes that you're using with your OLTP will also work with the analytics. And we have done some comparison between the InnoDB and the Heatwave. So as you can see, it dramatically speeds up analytics queries. In this particular example, we have used the TPCH database worth of 400 gigabytes with the InnoDB buffer pool of 400 gigabytes. And there were required indexes which were created for the MDS, and hints were also provided for certain queries. But as you can see, using this configuration, the MySQL was taking a lot of time, and the speed up in analytics in Heatwave is much faster, which is almost up to 400 times faster. So now let's look at some of the references of our customers. As you can see, MySQL boasts an impressive list of customer base. It covers a broad spectrum of the industry, including social media, telecom, finance, manufacturing, and many other industries. So all these customers use MySQL to run their mission critical workloads. So MySQL is basically ready for all your enterprise needs. So the MySQL database service that we just described, if you want to do the test drive for that, you can get $300 in credit and try the service for 30 days for free. So if you're interested in trying this out about all those great features that we just discussed and along with the heatwave, you can just sign up for this trial and see it for yourself. Uh, you can follow us on social media. You can connect with us on mysql.com, and we also have the Twitter, Facebook, and the LinkedIn accounts for MySQL.